showed you how to get the point of inflection without using the second derivative. But the main reason why we have second derivative in calculus here is because we want to talk about concavity. Now, concavity is the measure of whether your graph is looking upwards or your graph is looking what? Downwards. And then how do you get it? You get it by doing what we call the second derivative of a function. So remember, when we are differentiating for the first time, this is what you got. When you had something like this, f prime of x, this is the first derivative. Ne? But once you start to say something like this, f prime prime of x, this is the second derivative. Is the derivative of a what? Of a derivative. So let's show you then, how then do we use this derivative, this second derivative? They will say the graph of f of x is given and then it's shown here. Ne? Determined by calculations whether f is concave up or concave down. Now, when second derivative is positive, the graph is concave up. When second derivative is less than 0, the graph is concave down. That's what we're going to see. What do I mean by that? Let me show you so that you can also prove it for yourself. Let's suppose the learner has something like this. We take the same function and then we derive it for the first time. Number 8, they say by calculations, we should show whether this thing is concave up or concave down. So if you want to show it using calculation, you're going to say f prime of x. If you say f prime of x here, you're going to get this one multiplied by this one, which is going to give us minus 3x squared. Okay? This one multiplied by this one is going to give us minus 12x. This one is going to give us what? Plus 1. What do we call this? We call this one the first derivative. We don't want the first derivative because the first derivative doesn't tell you about concavity. It tells you about the gradient. So what is the first derivative for? It's for the gradient. What is the second derivative for? F prime prime of x. This one is for concavity. Doesn't give you m. It gives you point of inflection. So you're going to say this one multiplied by this one is going to give us minus 6x. This one multiplied by this one gives us minus 12. Are we still fine? Yes. Now let's look at this then. When x is equal to 1, is this thing concave up or concave down? That's what they want us to tell them. We're going to say f prime prime of 1 of minus 3. Meaning which everywhere we see x, we're going to have minus 6 multiplied by minus 3 minus 12. You type this in your calculator exactly the way it is. You say we have minus 6 open bracket minus 3 minus 12. And then we get what? 6. The answer that we got here is positive. If our answer is positive, it means which our graph is concave up. Concave up. It's looking upwards. The graph is looking upwards. Nah? Let's try when x is minus 1. When number 2, f prime prime of minus 2. Oh, minus 1. You're going to have 6 multiplied by minus, or minus 6 multiplied by minus 1. Minus 12. You get what? Minus 6. Okay, then you can tell them which you have minus 6. Then your graph here is concave down. So here you have concave down. And then after that, we have x is equal to 0. Let's try x is equal to 0. When f prime prime of 0, you have what? What did you say here? Concave up or concave down? So it's down. Yes. Yes, what? If f prime prime of x is equal to 0, then it means which you are at the point of inflection. The graph is not concave up, it's not concave down. It's neutral in other ways. So if f prime prime of x, now we're going to derive this exactly the same things that we spoke about here. We said, look at this, we need to use this exactly the way we use when the gradient is negative, f prime of x is less than 0. So now we're going to derive something, then we're going to tell them something like this. when f prime prime of x is equal to 0, we call this a point of inflection. It's not up, it's not down. When f prime of x is less than 0, this thing here is concave, is down. Yeah, this one is concave down. Yeah, and then when f prime of x is greater than 0, we say which this thing here is what is concave up. Yeah, but say, why is this important? You will see why is this important. You'll see now. So we have number 4. On number 4, they say which we should determine the coordinates of the point of inflection. Okay? How do you determine the coordinates of the point of inflection? Look at this then now. You are going to say on number 4, I have f prime of x. Number 4. I have f prime of x, which is given as minus 6x minus 12. Like this, okay? Now, if they say determine, it's like them saying determine the stationary point. If they say determine the coordinates of the point of inflection, I'm going to tell them which at the point of inflection, the second derivative is equal to 0. Just like I said, at the stationary point, the gradient is equal to what? To 0. So it means I'm going to tell them that I have 0 here, which is going to be equal to minus 6x minus 12. Take this one to this other side. It says which I'm going to have 12, which is going to be minus 6x. Divide by minus 6, divide by minus 6. It says which x is going to be equal to minus 2. So when x is minus 2, we're at the point of inflection. No? Now, they want the point of inflation. The point of inflation is going to have x, it goes with y. Where do I get y? Again. Where do I get y? You can't get y with f prime of x, Marsh. But Mara said the equations are made. We know f prime of x, we know f of a. It doesn't matter. Every time when you want y, you go to f of x, you go to h of x, you go to g of x. So you're going to have f of minus 2. Angish, what is our equation? Our equation, I think it says minus, no? Open bracket, minus 2, all cubed, ne? Minus 6, open bracket, minus 2, all squared, plus 1. Plus x, no? Okay, we can come and substitute here on this one. So we have minus open bracket. We got what? Minus 2, ne? All cubed. Minus 6 open bracket minus 2 plus minus 2. And what you get is your answer? Yeah? 6. You got 6, no? So when x is equal to minus 2, how does it make sense? Positive 6. Negative. Maybe let's teach you how to type it in your calculator. Paladina, you don't even know how to type in a calculator. It's squared here. So what are we going to have here? We have minus, open bracket, minus 2, shift cubed, minus 6, plus and then what we get is our answer? Negative 8. Yeah, what is this one? This one is what we call a point of what? Of inflection. As soon as you have a point of inflection, then they can ask you, for which values of x is the function going to be concave up? For which values of x is the function going to be concave down? So this one here, it's like you all say that this one is not up, it's not down. If I go this side, is it concave up or concave down? Is it looking upwards or looking downwards? If I go this side, it's looking upwards. Okay? So I will tell them which when x is less than minus 2, the graph is looking upwards. If I go this side, it's looking what? Downwards. When x is greater than minus 2, this thing here is looking what? Is looking down. Now let's try the following thing.